Today we're going to be talking about multiplying rational expressions. So there are 4 general steps that we're going to follow. The first one is to factor each piece, just like we did yesterday with simplifying. Then we're going to state our restrictions. The next step, so step number 3, is to cancel the common factors. And the last step is to multiply any monomials. Okay, so we're going to look at a couple of examples of this. Here's our first one. We have x to the third minus 8 divided by 7x squared plus 14x. We're going to multiply that by x to the fourth minus 4x to the third divided by, minus 4x squared divided by x squared plus 2x minus 8. Once we have this question, we're going to work on factoring each piece. And this is where, again, I talked about all of those different types of factoring coming back in the same question together. So if we have x cubed minus 8, and there's nothing that says you have to factor them in any particular order either. As long as you factor all of them, you're good to go. So x cubed minus 8 is a difference of cubes. That's going to factor into x minus 2 and x squared plus 2x plus 4. The denominator here, 7x squared plus 14x, has a GCF of 7x. Left hand side is x plus 2. In the second fraction, x to the fourth minus 4x squared, that does have a GCF of x squared, and then left hand side is x squared minus 4. So the x squared is great, but the x squared minus 4 we can factor into x plus 2, x minus 2, so it's important that you're factoring the pieces down as much as possible. And then x squared plus 2x minus 8 would factor into x plus 4, x minus 2, because we're looking for two numbers that multiply to give us -8 and add to give us -2. So now that we have that all factored, the next piece is to state our restrictions so that we don't forget about it. So I'm going to come down here and write our restrictions. And remember, we're just looking at the denominator of our fractions. Those are the things that would make the fraction, the denominator, be equal to 0, which we cannot divide by 0. So restrictions, we have x cannot equal, this is a monomial, so x can't equal 0. Here, x can't equal -2. Here, x can't equal -4. And then last one, x can't equal +2. So you need to have those 4 restrictions. So I'm going to go ahead and circle those. Okay. And then we're looking to cross things off. So it looks like it's multiplication. You're not actually going to multiply anything together right now, though. You're just looking for what is in common that we can cross off. So if we look here, we have an x minus 2 and an x minus 2. So x minus 2 divided by itself gives you 1. Those go away. I have this other x minus 2. I can't cross that off, though, because I don't have another x minus 2 in the denominator. This x plus 2 and the x plus 2 in the denominator can go away. And then with our monomial pieces, we can cross off parts of those. So x squared divided by x, we would just get rid of one x from both of them. And then we're going to write what's left. So in the numerator, we have our x. I'm going to put that up front so I don't lose it in this. Then we have x squared plus 2x plus 4. And we also have our x minus 2. In the denominator, we still have 7, and then our x plus 4. So with this, that's your answer. That's as simplified as it gets. Okay, there's nothing else we can do to that. We can't cross off parts of these things at all. So here's your simplified answer. And then we already circled our restrictions down here. Okay. So let's take a look at one more here. We have 2x squared plus 13x plus 15 divided by 4x squared minus 25. We're multiplying that by 4x plus 10 divided by x squared plus 9x plus 20. So we're going to factor all of the pieces. Again, keeping in mind that you can factor them in any order that you want, but we know that we're going to have fraction times some other fraction. Okay? The easiest one of all of these, I would say, is the 4x plus 10. So those have a GCF of 2, and left inside is 2x plus 5. Next one I'm going to go to is x squared plus 9x plus 20. That doesn't have a leading coefficient with it at all. So we need two numbers that multiply to give us 20 and add to give us 9. That would be x plus 5 and x plus 4. The denominator of the first fraction, 4x squared minus 25, is going to factor, that's a difference of squares, so 2x plus 5, 2x minus 5. And then the last one, 2x squared plus 13x plus 15. We know that we need 2x and x. Our back two spaces need to multiply to give us 15. So we have 1 and 15, or 2 and or 3 and 5 to use. And when we add those things together, we should get 13. So that means that we need to have 2x plus 3 and x plus 5. So that would give us 2x squared plus 10x plus 3x, which is our 13x, and then plus 15. All right, so we're ready to do restrictions here. So in this one, this is where it might be beneficial for you to write some work out, at least until you get the hang of this. So if we're figuring out when that particular piece would be equal to 0, we would set it equal to 0. We would subtract 5 and get 2x equals negative 5. And then we would divide by 2 to get x can't equal negative 5 halves. If we have 2x minus 5, then we would add the 5 and divide by 2. So x can't equal positive 5 halves. Here with x plus 5, x can't equal negative 5, and x plus 4, x can't equal negative 4. So those are our 4 restrictions that we have for this question. Now to cancel out, we're looking for the exact same thing in the numerator and the denominator. So I see an x plus 5 in both of them. Those can cross off. I see a 2x plus 5 in the numerator and denominator. Those can cross off. That's it in terms of things that simplify. So we have our 2 out front and 2x plus 3 in the numerator. In the denominator, we still have 2x minus 5 and x plus 4. So this is your answer. You could distribute that 2 into the numerator if you wanted, but that's just another place to make a mistake and potentially lose points. Then you will get full credit for this answer here. Okay, so you need simplified answer and the restriction. Remember, factor, write restrictions, cancel pieces out, and then you can multiply monomials. And again, that means that if you have 2 different monomials, multiply them. But we don't have that here. And that's it.